Welcome to the Ardan Labs podcast. Our special guest today is the one, the only Dr. Aditya. Doctor, man, thank you for joining us today.
Hi, thank you for having me.
For anyone who possibly doesn't know who you are, could you give everybody like the 2-minute spiel on what you're doing today?
Yeah, sure. Well, I got a PhD in math, computer science, 2008.
That's it? Just a PhD? Come on, Doc.
Yeah. From there, I started a contract software engineering firm. We put out 35 different product lines. It was 50 different applications. And then in 2016, I started Elephant Learning, which is an online math academy for children. On average, children in our system learn about 1.5 years of math over the course of 10 weeks when they use it just 30 minutes per week. And we've helped over 175,000 students. We've taught nearly 210,000 years of mathematics.
2010 years of mathematics.
210,000 years.
Over how many students?
175,000.
What's the name of the platform again?
Elephant Learning.
Elephant Learning. When I think about the platform that you built, the first thing that comes to my head is the Khan Academy. Why is that? They just did an amazing job getting integrated into the grade schools.
Well, Khan Academy, I believe, is free.
Oh, okay.
Yeah, but a lot of what Khan Academy is recorded videos, and the difference between what Khan Academy is and what we're doing is probably, first of all, I don't know what Khan Academy is doing for grade school. So we're focused on counting through algebra. And so this kind of mathematics is a little bit more fundamental. And so like the way you would be required to learn it would be through these experiences. Like, give me 5 things, give me 4 more things. So like what your mother might have done with you at the grocery store. But what we've done is we've organized it, and then we've combined it with adaptive algorithms so that then the system keeps pace. And then, we measured the growth after that, and we got what we got. But like, it is kind of amazing. My child, he's 8 now, but he's been working on fractions, decimals, and percentages for the last, 4 or 5 months. And it's not uncommon for us to get children to about that point before parents give up and say, hey, they've learned a lot. And then they might come back later for our algebra, which I think is important because algebra is really the introduction to the written language of mathematics. So like, I think algebra is the mathematical equivalent of the 3rd grade reading. Like, if you don't have that, then you can't read the texts that come after that and understand it, like statistics or any of the sciences or engineering or your STEM, your STEAM. Like, you want to play with computers, your technology, right? So like, I don't know.
Yeah, your basic algebra is critically important. I know that I didn't really go beyond Calc 2 in uni, and even that Calc 1, Calc 2, I struggled. I wasn't really mature enough, and I'm not even that strong in it. My wife is really strong in math. So I love reading white papers, but normally you get to about page, or at least after the introduction, and I see that first sigma, I'm like, oh man, I'm in trouble now. Like, I don't have enough of that background. That platform that you've written, that you have for the math, is it good for somebody like me too that has the basic algebra, hasn't been to school in God knows how long, and wants to learn enough to be able to read a white paper?
Well, I think it would be remedial because, again, what we're doing is we're focused on just the language, right? So like, if I can get you to understand what a variable is, if some of the definitions that come along, if I can get you to understand why the quadratic equation works, these kinds of things, right? Then you kind of have the basic tools. But like, what's happening in the school is kind of different, and the reason why it's different kind of makes sense if you look at the history of human beings. But like, they kind of are like, this is how you do it, and then there's a lot of doing, which I think is also useful, right? Solving for X is a type of puzzle problem solving, that's helpful. And like, I feel like I'm always doing that just in communication. What is the missing variable that I haven't told you, that like if I can illuminate it, now you understand what I'm talking about. You see what I mean? And so like,
So
I
I
don't
feel
know,
like
right?
I feel like you're falling into the idea that I talk about with trying to teach people how to write code. We teach people how to write before we teach them how to read, and that
Well, I
really
mean,
sort
the
of
whole
hurts.
doing of teaching children to code, because I learned, is this is the syntax, and but like in reality, what it was this is the logic. This is what an if statement is, and you have to get to your third year of computer science, because at least back in 2000. You had to get to your third year of computer science before they said, check this out. Here's a whole bunch of programming languages that are basically the same. And here's a whole bunch that are, functional. They're kind of different in a way that I'm not going to be able to describe on this podcast. and 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 now it's demystified. Now you can go do all of them if you want to, right? Like you're just talking about, does this one use a semicolon or not? And so, like, yeah, like when people say ChatGPT can code, absolutely. If I told it exactly the logic, it'll spit out syntax correct code. That's perfect. I mean, if you're willing to wait the 5 or 10 seconds, I mean, I could type it in 10 seconds.
Yeah, I mean the chat GP the large language models are fairly good at writing you a function given a very specific set of input and output for a given
Yeah,
language and its SDK. And I think that's fair.
there's a lot of business people out there, by the way. They have that logic. If they could just use ChatGPT and somehow spit out the thing, it's just there's not a good platform yet for it, right?
Well, for any DSL language like SQL and stuff, I think there's value. But I think knowing how to take that function now and integrate it into a larger application and architecture, and like I'm waiting to see how well the LLMs at some point can do that kind of stuff, if at all, or the
Yeah,
generative AI, right?
I don't know because that's a much
Uh,
different task. That's someone would
yeah,
have to build that. Someone would. I mean, that's the thing. Someone has to build the developer AI for that person. So it's like when these people say, "Hey, like it can code for you." Yeah, great. That just means the thing that you have to build now is more advanced.
all right, this is good. We're gonna get back to all this stuff, but this podcast is really about you, and I want to kind of hear your journey to how you got here. But a couple quick questions up front. First question is, what year did you graduate from high school, and where were you?
I was in Pueblo, Colorado, in
98. All right.
yeah.
And then I want you to clear your mind here. I want you to give me that first memory that you have of interacting with a computer.
Okay.
The
So
very
like
first memory.
yeah, I mean the first memory I have is like in middle school there was like some intro day like at the beginning. What do they call that? I can't remember now. Anyway, there was a Mac computer and they had that encyclopedia on it. And you click it and the world spins. And I showed someone else's mom like, look, if you click the world spins. And she told me uh, I wanted to see my son do that.
That's funny.
Yeah, that was
But but I feel like that was almost intuitive for you when you walked over to that computer and started
no, someone
clicking.
showed me that.
No,
Yeah.
someone showed you. Okay, that's cool. So in '98 you graduated high school, but talk to me a little bit about sort of high school and the things that you were doing, interested in, like what was occupying your time.
Yeah, okay. I mean, a lot of it was coding. So like when I was in middle school, I had taken like the computer classes. So the first year was like word processors. Then the second year was typing, and then the third year, or maybe these were quarters. I don't really know semesters. The third class, but it was eighth grade at this point. I said to the guy, "You don't have any more computer classes." He says, "Well, okay, fine." So he gave me a book on BASIC, and then I was in the computer lab that was next to the Mac lab. It was the Apple lab next to the Mac lab. It's the Apple II GSs, and if you just turn on the computer with no disk in it, it's a prompt, and then it was BASIC, and so he used a book on BASIC, and here you go. And then I don't remember like if I recruited people or if he recruited people, but I remember that by later, there was like 4 or 5 of us now in an Apple IIgs room, and and yeah, like we were writing stuff. I don't know, but like the next year, going into high school had a block system, so it was like 90-minute courses. It was like so that one was homeroom.
Yeah. Yeah.
So I homeroom. I said I'll read the C++ book, right? Because like I don't know if I can use. I mean, Apple IIgs is. You know what I mean? Like I got a Windows machine at home, so like I went down to Barnes and Nobles and I bought a book on Borland C++, and this thing had a CD-ROM. I put it into the Pentium 90 my dad got me, and the CD-ROM had like learn C++, and it was like it would use the compiler. I think. I mean, put it together. It's like here, type in the code. Right, like here, you need to use an include statement. Try it, put it in. It should look like this. Put it in there and hit go.
Yeah, they gave you an IDE. The Borland IDE was pretty good, actually.
Yeah.
So,
but
yeah.
like this was a learning program for C++. So within a month, I basically learned C++. I don't know if it was a month or 2 months. So then in homeroom, I was writing stuff, and so like a lot of my evenings, I mean, I did debate, I did tennis, I did swimming. I did things, right? But a lot of my evenings might be just kind of messing around on that, just finish up the homework, and maybe I was messing around on the internet. I remember like some dude through my IP address called up my house, like looked us up in the phone book. Yeah.
Whoa. Whoa.
But then like once he's done that though, the question becomes how did he do that?
Yeah, yeah,
So I called him back.
yeah. So how did you do that?
I don't remember now, but like back then it was easier because there was a phone book.
Oh, it's wild. Plus, that was, I mean, you're talking 94, 95. You're still dealing with dial up. Machines are still expensive. So,
Yeah.
how did your dad get you that
Oh,
machine?
check this out. Back then, you could go to the command line and you could tell DOS to send a ping of 1 megabyte to an IP address. And that would crash that Windows machine. Could you imagine that? You're just on the internet and boom, your computer crashes.
Peer-to-peer networking. Boom. Yeah.
Oh my gosh. Yeah, anyway, that was the
So-
night.
So how did your dad, what did your dad do that you were able to get a machine sort of that early on?
Well, I mean, I don't think the machine was super expensive, but my dad, he owned hotels. Yeah, he owned hotels. His father was a music director in India. And in the he passed away when my father was 25. So my father then came to the United States, and then he was a pharmaceutical sales representative. He was selling actually this stuff. And in the 80s, he partnered with some people and he opened hotels, and motels. I don't know. They're indoor. It was better than a Super 8. But back then, to be honest with you, it was Super 8 or Ritz-Carlton. So like, he kind of invented that middle space, honestly.
He's like, you saw the TV show Schitt's Creek when a guy inherits the motel.
No, I didn't watch it.
Oh, now you got to watch it just for that.
Maybe.
But yeah, no, I get it. That's a kind of a big shift to go from pharmaceutical sales to.
Well, he was doing both. So like he'd be on the road because like he had all of Southern Colorado. So he'd have to drive from Pueblo to Durango to see doctors sometimes. And that's a 6-7 hour drive. So yeah, I mean, he was, I don't know.
It's just opportunities come by and you take, some of them you pass up, some you take. He still has all these hotels?
No.
No?
So there was 10 people. They built like 50 or 60 of these things. Then they split up. So then each got like 3, 4, 5. And then he sold his and he passed away in 2018.
There's a street here in Miami. It's called 8th Street, where I live. And if you drive down for 2 miles, there must be like 24, if not more, motels on this road. And anytime I drive down, I laugh with my wife. I'm like, baby, we got to stay at this place. And she looks at me like I got two heads, right? Because these are motels on the side of the road, but a busy, busy road, you know? And I'm just always like wondering if anybody's staying in them, who's staying in them. I'm looking for cars. Like, I don't know, man. The idea of a motel here in the States, at least, has gotten like, you're in a motel. What bad things happened to you?
I know what you mean, right? Like, I don't know, because like even then, right? Like as these things aged, right? Now it looks like, well, that's more like what a motel used to be.
All right, so you're doing all the traditional things in high school. You're playing sports. You're doing other stuff, but when you're home and you're not doing homework and other things, it sounds like you're learning how to code.
Yeah.
So when you're about to
I
graduate,
had a book on game programming. I had a book on neural networks.
did
Uh,
you code anything like that? Were you just coding games at home, or were you just
also,
like,
like, yeah.
yeah?
Go ahead. Sorry. Go ahead and finish. Sorry.
No, 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 no. This podcast is all about interrupting each other because thoughts pop in your
Okay.
head. So
Well, I didn't know. I like at first I thought like, well, but then I
it's all
thought,
good, man.
wait a second, he might go a different direction.
No, no, you take this in the direction you want to take it in. But I'm kind of curious now. What were you like when I was learning how to code back in the late '80s? I was learning basic, and I was building all sorts of games, not like high graphical games, but that's what I would build, right? Games
Yeah,
I couldn't even beat myself because you need some visual component to what you're doing, even if it's terminal based. So,
I know what
what
you
were
mean.
you sort of building to learn?
Yeah, so like this book was like on how to basically build Wolfenstein, and it talked about ray tracing, and it had some pictures. So it was
Ray
like
tracing.
yeah,
Whoa.
yeah. Yeah. So ray tracing is crazy, 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 and they're doing it now, and then they're like, oh, we're enhancing it with AI or whatever. Like, fine, right?
Well, the
But
graphic cards have support for all that now,
yeah,
right?
yeah,
Like
yeah.
they're
But
not
like
doing.
the idea is like, could you trace a ray of light back from the light source, bounce it off everything in the room, and then trace it back to the eye? And um, so like those images would come out like hyper realistic, actually, because like. You don't get the granularity of real objects. You just get like it looks like Pixar basically. And so that was very interesting. But then they go into ray casting. So ray casting was like you cast out a ray and you hit a wall and you're like, oh, I could draw a wall here. Like, and they're like,
Wow. So you were
this is
doing way more stuff.
computationally possible.
Wow. Yeah,
Yeah.
you're doing much more than I was even thinking about. The idea of ray tracing wasn't even on my. Then again, I'm on a K Pro 2 CPM machine with the most basic terminal you could ever imagine, right?
I know what you mean. This was
Yeah.
I think a 386 or a 90 Pentium 90 back then, and then so like um, the neural network stuff. There was no point in coding it because like just they had the code on the disk, and then you'd run it, and then it'd be like, you know what? There's no way on this computational power that this is ever going to work.
You could do anything of significance, at least.
But I understood. I mean, I read through the book, and then it took me years. I think I remember thinking about some of the things I read about later, and then trying to. Oh, I think I understand now how this mathematically would work. So like I don't think it was a useless scenario. But like now, when you look at what's happening, when people talk about what's possible and what's not possible, it's like, like did you try to look at how this stuff works? Because I just don't know about what you're talking about here.
So when you're now about to graduate, I'm guessing the only option was university for you.
And
So what were you
yeah,
thinking there?
well, I didn't have a lot of self confidence, so I applied to oh my god, what was it called? The University of Southern Colorado and the University of Denver. And so, like, the University of Denver picked it up and they gave me a scholarship. And so, yeah, it was pretty easy to just
So
drive
that's
up there.
good. So you got to move away from home. You went to the university. I'm assuming you're studying some form of engineering, computer science at that point.
Yeah, so coming in, I chose math and computer science. Math had a like a minor requirement. So it was like take 20 more credits, you get a major. So it's like, yeah, fine, why not?
And in those 4 years, that's what you went through all those. But the computer science classes must have been really engaging for you after having to do all that self study and
So I
high school.
started in data structures and algorithms. I didn't start in C++. I don't know. There was no like test out process. The advisor drew a linked list. I didn't know what it was. I said I've never done anything like this, and then I drew him a neural network. But I've been playing with this.
It was all Java too, right? At that time, like my program was Pascal and C back in the late '80s.
Yeah, no, I think the first year was C++. They said,
Oh,
yeah,
okay,
C++ will be boring for you. Let's just put you in data structures and algorithms. It doesn't seem like
gotcha.
you know that stuff. So that's where I started, and yeah, I thought that stuff was great, honestly, because it's like the game programming book. Like it's talking about these things, and it's like, this is computationally possible. This is computationally not possible. Here is a framework that they're teaching you that allows you to compare, contrast mathematically.
But what was your favorite? What was your favorite computer science class then, in that undergraduate degree?
I liked computational geometry. I don't remember if that was graduate or undergraduate anymore.
What is that computational geog? Is that leveraging algorithms to draw
So like it's
shapes?
kind of maybe more of like geometrical algorithms. So like a problem they might study is the art gallery problem. If you have a space, how do you figure out where to put the cameras? Right? Can you come up with an algorithm to do it? If you had a robot and it doesn't have anything but like XYZ sensor, could you map the entire? So it's like, and then how long would it take you to do it, right? Because like a lot of the things were n-log n because they were sweep line algorithm type
Are
things.
some of these like NP problems where you need the solution already to
No,
know?
no,
So
no.
they all could be solved. It's just whether it
Yeah.
would be brute force or not.
So NP is solvable, but the problem is that it's solvable in non-polynomial time, meaning
Right.
that it takes a really long time for us to figure out the answer. Um, and so like and the question of P equals NP because there was like this these set of problems that we don't know if they could be solved in polynomial time. But no, these are all kind of like, and yeah, like sometimes you'd get one of these problems, and the question is can you even solve it? Like, um, so like those were fun. There was a lot of stuff like that, and it was good stuff. Yeah.
So in these 4 years, you finish with the computer science engineering degree. You have the
3 years.
mathematics degree. Three. You did in 3 years.
Yeah.
Why'd you do
Graduated
it
in
so
21.
quickly? Why? Why so quickly? You just wanted to get it done.
I mean, it was done.
You weren't going. You were. Were you living at? You weren't living at home at the time. You weren't going out. You
No.
weren't enjoying any social aspects
Well,
of.
I was in the fraternity house, so
Okay. All
I
right.
went to
That's good.
parties. I did what everyone else did, I guess. I don't know.
But you graduated a year ahead of time. That's
I mean, I
amazing.
had the. What are you gonna do? You got the credits.
I don't. Oh, you already. Oh, okay. That's fair. So, once now that you're graduating with the undergraduate degree, what's your thought? You want to get into the workforce? You want to keep going? You found something super
So
interesting?
I was in the fraternity house. It's the summer after I graduated, um, and I don't know if I've applied to jobs, but I remember that like I was doing something for my uncle in India, and most of the days were playing StarCraft. Because there's like three or four other people in the house for the summer, and then we just start like just launch up a game, and then I talked with my dad, and so like he says to me, "Well, are you moving back to Pueblo?" And I'm like, "No." I mean, it was only $300 to live in the fraternity house for the summer, so like, yeah, no, I'm not doing that. And he's like, "Well, you think about getting a job?" I was like, "All right, fine." I guess, yeah, fine. So like I think very quickly I ended up getting a job for Dish Network, But this was in the tech bubble burst. Like this was literally, I think the market started crashing in March, and I graduated in June. And so like that psychological sentiment of like, hey, oh, it's not the same, like party that it was before, with the money and etc.
Yeah.
Was there. But like, Dish was a nice place because Dish, what it was one of their first PVRs, they called it DVRs, the digital video recorders, and it was high def. It was the first high def one. So this is 2001, and it was running Linux. So like, it's a Linux box. It had a hard drive. It was basically a computer running television. You know what I mean? I'd done a lot on Linux at this point.
I remember us hacking DirecTV set tops to like pirate the signal. You put a dish up. We were putting something in there instead of the card, and we were like pirating. Like this was like the age of satellite TV, really.
Yeah, I know what you mean. But like, so for Dish, what ended up happening, I mean, I assume that's where you wanted me to go.
Yeah, keep going. Yeah. So this is your first job. It's like 2001.
Yeah.
Got
So
you
what
on
ends up
graduate
happening
ticket.
is the first thing I think they had me work on was caller ID. So they gave me this box, and like you plug it in, and it mimics a phone, and like you hit it, and then boom, like you get the caller ID information. Go put it on the screen. And then the next thing I know is that like I'm working on the guide. Like I'm fixing bugs in the guide, and I'm fixing like 10 or 15 of these a day. And then maybe a little bit later, so the situation is this. So like Dish, sadly, I don't know, like maybe things have changed. They don't seem to have forethought. Because in my previous jobs, I had worked at Lucent before that. I had worked at like some sort of a startup right out of freshman year. But like these guys were just, yeah, go do it. And so like every day when I would come in and I would download the current code, it was chaos. It was completely different than yesterday. There was 15 people coding this thing. 15 people. Think about it. So like 15 people submit code every night, and you turn it on the next day, and the thing is completely different. And I just said, one day we're gonna turn this on. It's gonna work, and they're gonna say freeze code. Let's just send it.
Here at Ardan Labs, we believe in empowering companies to reach their full potential through innovative technology solutions. Trusted by small startups and Fortune 500 companies alike, we specialize in high-performance software consulting, training, staffing, development, and now AI. With over 14 years of experience, Ardan Labs has trained over 30,000 engineers and served over 1,000 companies worldwide. Whether you're mastering Go, Rust, Kubernetes, Terraform, or blockchain, we're your strategic partner for performance-grade solutions. Let's elevate your tech journey together. Reach out to Ardan Labs today.
And that's what happened.
No, that's unfortunately not what happened. So what happened was that, like, theoretically speaking, because of this problem, you guys are clearly just not working hard enough. 60-hour work weeks. So 60-hour work weeks and going to graduate school, and then like this project had been going on for 3 years. So like, I don't know why, like, we couldn't put it out because the guide itself and like the data layer of the guides were slow as hell. And so they wrote me up. They wrote me up for walking in at 10 a.m. The VP saw me walk in at 10 a.m., pulled my hours, said, "You haven't been averaging 60-hour work weeks. The project is delayed because of you."
Wow.
And then I went and I proved them right, because that weekend, that was Friday, I had to work, and I said, F this. I don't care who wrote the data layer. I'm going to go in there and I'm going to find out what is happening. And I got down to this function, which was to get a sorted channel list, which, by the way, everything calls. Think about it. Channel up. Okay, fine. What's the next channel in the list? And this guy bubble sorted.
I guess he thought the list was going to be small, so it didn't matter.
It was a vector. So it had a dots. It was a C++ vector. So I deleted the function and I said return dot sort. And immediately.
Oh, it already had sorting on it, yeah.
Immediately. It had quick sort. You go look up the spec.
It's already there.
Immediately, it was a vector of integers. Immediately, the system started behaving better. And I said, okay, you know what? If I'm ever going to get out of 60-hour work weeks, I'm going to have to go through this. I'm going to have to fix this up. And by the time I was done, the guide was so fast that you could hook up a USB keyboard to the thing. So you could definitely keep up with the remote, but you could hook up the USB keyboard. You could hold down the keys and it'd keep up with it.
Wow.
When I inherited it, you'd hold down the keyboard. The guide would keep scrolling after you let go.
Did anybody say thank you after all that?
No. they paid me.
So I know, but it's one thing that I'm paying you. It's another thing that you took some initiative to fix it. But while you're there for those 3 years, you made a decision to go to graduate school, which you hadn't made that decision initially. So what caused you to decide to now go to grad school?
I went to graduate school also.
Oh, so the decision was to do that and work at the same time anyway.
Yeah, that I guess was what ended up happening. That was a neat trick, I guess.
And the graduate school was at the same university in Denver, or you chose a different school?
Yeah, University of Denver.
So after 3 years of that, I imagine you finished your graduate degree too at that point, at the end of those 3 years?
So it took me from 2001 to 2008 to get the graduate degree. I didn't try to get the master's thing where it's like, well, when you hit this many credits, you could just get the master's and then continue, or you could just continue.
Gotcha.
I don't know why I decided it that way. And
so what do you do after this job? What's your next gig after that?
Well, there was some contract software engineering places, and then I just decided to focus in on doing the research. So around 2005, basically it was research.
Okay. But what are you researching?
Scattered lattices, that's what it was. So it was these lattices, they had a duality with these topological spaces, which were also had an order on them. So it's really interesting because there's an order on both sides. You know what I mean? And whatever's true on one side happens to be true on the other side, and it means something. And so it's kind of really cool because you could go over to one side, figure out something, means something about these lattices. And it was distributive lattices is what it was. And so the topological spaces were scattered. And so then we called them scattered lattices. So we were describing the properties of the scattered lattices at the time. But it turns out we had in hand a paper that did all of that. I just didn't read it. But
what were you trying to accomplish working on this? What was your end game? What were you trying to?
There's no end game for these people. So the idea basically is I'm interested in this. I have these questions. I think they're interesting questions. Hopefully other people think they're interesting questions. Sometimes you go and look at papers and say, oh, look, here are these open questions at the bottom that I could answer, right, to publish a paper. But the goal is, the end goal, in retrospect, I figured it out, was you have to do something to extend human knowledge. So the fact that the paper already existed means that I wasted that year and a half, but whatever, right?
But it gave you a deeper understanding, at least.
It gave me the confidence to know that I could do it. If I was maybe several years earlier, I might have done that one. So I had to do something else, but fine.
And what did you end up doing?
So then after the scattered lattices, there was some sort of result that I had. I published. Why can't I remember it now? I have to open up my own paper to figure out. Well, anyway, I came up with a duality between some meat semi-lattices. And what was interesting was that the space on the other side, it didn't have an order, but it had a betweenness. And then the thing that I think got me the PhD was that to create this duality in one of the proofs, I had to use compactness twice. It was a flowering argument. Only happens really in the context of convex spaces where betweenness matters, which I don't know if anyone's really kind of looking at. No one was kind of looking at the time, but that's what it was. Yeah.
So now you got your graduate degree. Are you still at that point? Now it's 2008. We're having a mortgage crisis, so that's not fun.
Yeah.
What is your next sort of move now that you know you're a doctor now? So right. So what's your next move?
Well, so the last year of my degree, I had gotten a job over at a contract software engineering firm. I was dancing a lot of tango, so I was picked that up in Prague in 2005. And
Why? Well, like, you got to tell me that story, man. Was everybody in the city dancing tango, and you're like, if I don't learn this, I'm in trouble?
what happened was that in 2005, my advisor went to Prague. Apparently, he liked to go to Prague every 7 years on his sabbatical. So he was out in Prague for a year. So for one DU quarter, they were nice enough to arrange it that I could go out there. Thirsty all of a sudden. Anyway, so while I was out there, he had an office with one of his colleagues in the University of in Charles University in Prague, and that building was like on the other side of the Charles Bridge. So like you're in Old Town, you go over Charles Bridge, and then there's like a church there. And attached to that church is the Applied Mathematics Department of Charles University. And so one day I was leaving there, and well, there was a program on Ramsey theory, I think it's called. I'll say Ramsey because it reminds me of that Egyptian guy, but I think it was called Ramsey theory. There was something on Ramsey theory there, and so all these graduate students from all over Europe were at Charles University in the Applied Mathematics Department doing that. So like there's this girl leaving, and she says, well, I need someone to walk me to this bar because I'm gonna be dancing tango. So like 2005 Prague, by the way, was still like it was touristy in the center, but you could get lost and it was a problem. So like we were walking each other kind of story. So like I walk her down there, and I thought that I'm gonna try to dance a little bit and see what it is. But like tango is really interesting because unlike a lot of the other dances where like there's like a set pattern of movements, it's completely lead and follow. So when I got back to Denver, I thought, you know what I'm gonna do is I'm gonna try to learn tango. So as I was completing my degree, I was also dancing tango.
Did you like I like salsa in a sense that it's mechanical.
Yeah.
You know, like obviously people who dance it really well, it feels artistic, but there's sort of mechanics to it. Right?
Correct.
Is
yeah.
the tango sort of similar?
So this is what I'm trying to say is right. So like salsa was quick, slow, quick, slow, quick, slow. Tango's whatever you want. You can slow, skip a beat, slow, quick, slow. So it's completely lead follow. So it's completely.
How good is your tango right now? Are you still keeping up with it?
I haven't danced in a very long time, but last year I went and tried to take some practicas or whatever, and yeah, I did okay. I wasn't like awesome, but like I wasn't beginner, so like that's.
Yeah, I'm sure it's like riding a bike. You just need an hour.
We'll find out one day. We'll find out. I don't know.
But that's kind of cool. You got to move to Europe and sort of live there for a little bit of time.
3 months.
You came back, and then, yeah, I mean, I love Europe. And being able to, normally I can only stay for a couple of weeks, but being able to stay for that long had to be. Did you almost not want to go back to the States after that, or you were kind of ready?
I think I was ready to come back.
We're in 2008. We're still about 16. Now, what 2008? Yeah, like 16 years, right, from
Yeah.
where we are today. So I'm trying to get to a sense of, where do you start thinking about being an entrepreneur and sort of starting this company that you're in now? Like, what's in between 2008 and today that gets you there?
Yeah, sure. Like in 2009, I decided that I would go out to Ukraine. I had met someone dancing tango, and then turned out she was married, and she had said, "Oh, I met someone on a dating agency." So I went and checked out what is this dating agency, and it was like completely different than an American dating agency, because like you put your profile up, and then the next day you get 100 emails. So I'm like, this has to be fake. And so then I called him up and I asked him. So like I don't know, like I had like this breakup clearly caused some like mental disturbance, and I don't know. I had to get to the bottom of the scam.
When the math doesn't add up, I'm like that.
Yeah,
When the math doesn't add up, it drives me crazy.
so at some point I said I said they got a trip to Ukraine, and the guy in my office, because now I'm just working full time. He's like, yeah, dude, you should get out of town. Like that's totally what you need. You get out of town. And my brain, it wasn't working properly, right? It was like, you should go over there and you should meet some of these women.
Oh my God.
So I went out to Ukraine and Odessa, and it was really interesting because Bob Saget was out there. It was just random, thing that happened to me.
You met Bob Saget when you were out there?
Yeah, so what happened was that when I realized that my brain wasn't functioning properly, I called these people up and I said, I don't want to go on the trip anymore. And they said, well, is this because Bob Saget's going to be out there? And I was like, no, I did not know about that. And they're like, there's a lot of people canceling, and we want to assure you that everything's going to be great for this thing. And I heard you guys are going to be on camera. So if I go in August, I might not get the good hotel. Not the one you want to show on TV, right? So I said, give me a minute. And then I committed to it, right? I called him back, gave him a credit card. And so I ended up in Ukraine. So the first night after we leave dinner, they said, we're going to go to the cash exchange. We go up the street and you got to change dollars into hryvnia, and two guys say, we're going to go over to the Irish pub and get a drink. The rest of the group starts heading back towards the hotel, and I'm debating with myself, do I want to go get a drink or do I want to go back to the hotel? I said, let's go get a drink, because then maybe the jet lag comes off. So I say, hey guys, I'm going to go join these guys to go get a drink. They're like, no. I'm like, what do you mean no? I'm just going to go. They're right there. They're like, no, wait. This doesn't even make sense. Watch this, right? One of them will come back to get you. It's dangerous here. Fine, right? So guy comes back and gets me. I go get a drink. Literally, I get back to Denver. I'm like, I don't believe this BS. Right? They're like, they didn't want me to walk around alone.
How long were you there before you went back to Denver?
It was a week. It was a week-long trip.
It was just a week.
So I went back out there a month later, and I didn't have my job was starting to kind of fall apart at this point, and some just weird things were happening, and I just thought, you know what, it's time to eject. So I ejected, and I didn't eject maybe politely at this point. And but I ejected, and I said, yeah, I'm moving to Ukraine, and you can pay me to work from out there.
So you moved to Ukraine in 2009.
Yeah.
Wow.
Yeah, kind of. I bought tickets, and then I just didn't come back. And but I went out there, and they didn't keep me on board, but they said, hey, we'll keep you on as a contractor. And I was doing the work. And basically what happens is that one day the customer calls me up and he says hey, I just got off the phone with your boss. And I was like, what? Yeah, what's up? And he said, Well, he thinks you're unreliable because you're in Ukraine.
Oh my God.
So like, and he says, how much are they paying you? So I told him, and he said, okay, I'll send you out a contract tomorrow for $5 more. And so then now I'm no longer working for these people. I'm working directly for the customer. And this guy says to me, hey, I got an idea for a thing. I need you to help me do it. So like, the name of the company was Digidata, and they had a back-end cloud system, sort of like Dropbox. And Dropbox was taking off, but like so they were actually partnered with companies like Verizon and all these large telcos. So like the large telco would then wrap into your internet connection your Dropbox storage drive sort of story. And basically he was trying to figure out like how can he get people to use it, because then they become sticky. And what he came up with was, what if my iTunes library could back up to the cloud? And then I could play the iTunes library from my phone. And he called it Thunder. And so like, what I had to do was figure out how iTunes communicated its shared library, because that's what it was. It was like he could go to his friend's house, he could launch the app on his friend's computer, theoretically speaking, and there within the iTunes would be the shared library from the cloud. And so like I built a little app in the middle that to iTunes looked like an iTunes library, but streams it from the cloud.
You got all that working.
We got the prototype working that summer.
Sounds like you had to do a lot of reverse engineering for that. I'm sure there weren't public APIs.
Yeah, I just launched Wireshark and
yeah.
it was all HTTP, and it was like their own custom protocol. And I mean, in the several years they switched over to cloud anyway. So
and you got that working? Were you ever able to deploy and sell it?
That was deployed in Verizon, Telefonica, Telemex, all those logos that are on that Elephant Head Soft website.
Amazing.
The telco logos.
That felt good.
Yeah, I mean, sure.
So, but you didn't have any real ownership in that. You were just a contractor at that point.
Yeah.
Stuff.
I mean, the contracting business is nice, especially for people that are out of college or like, because like you're talking to people who have real problems, but like as of yet, you have not encountered.
So what happens now after that? I mean, how long did it take you to build that? It was a couple of years? You're talking 10, 11?
Well, so like we built the prototype for Mac OS, then the port to iOS took a month. So like I think that was 2010 at that point, but I was still in Ukraine. I skipped my flight back. I was working first out of like this guy's phone office, which is an interesting story, and then I managed to rent an office there, and we were working out of it.
You weren't an illegal alien at that point? Like, they didn't have visa issues or nothing?
Well, I went over to Prague, and I got a visa.
So how long are you contracting on this job in Ukraine?
Well, I managed to work with Digidata as we started Elephant Head Software from 2009 to I think about 2013.
Oh, that's pretty good. That's 4 years right there.
Yeah, we did all sorts of different projects, not just the one.
And then what happens in 13? You decide you want to come back to the States?
Well, I came back in April of 2010, and then I was back out there for about a year, from 2011 to 2012, and then I've been here, and then we had an office out there until about 2020.
So you stopped working for them in 2013, or you stopped working for them in 20?
Well, by that time we had Elephant Head Software. We had 3 or 4 different clients. Digidata, I think, went out of business. Like my guy over there basically said, the CEO. was retiring. He's retiring with a paycheck.
So then when do you start the elephant company here?
Oh, Elephant Learning. So in 2016, we started Elephant Learning, and what it was that around that time, we had lost a very large contract with Pearson because of I don't know, God knows what. Like they were on John Oliver, but like long story short, there's this John Oliver, and then within 8 months, R&D budgets were cut, like from 70 million to 7 million, and I mean R&D budgets are your software development budgets, so we were cut. They said, "Oh, well, you've already used your budget for the year. We'll call you next year." And so, like, basically, at that point, I'm looking for a new thing because another contract was also kind of coming off. They had just been sold. So they were like, well, we're going into this new company. And so, like, what happened was that I met with one of my professors from college, and he had a National Science Foundation grant, and I was like, oh, okay, so like start get some money back into the system, get this thing back moving the right direction. And so like when I met with him, what he told me was that 4 out of 5 students start kindergarten unprepared for the kindergarten curriculum, and that what this boils down to is that they don't understand the language of the numbers, meaning kindergarten thinks counting to 10 is sliding over 10 things and stopping on 10, but most parents think counting to 10 is just saying the numbers out loud. I was like, yeah, just as you were telling me this, I was thinking maybe I can get them to count to 100. This
Yeah.
right? So like and my first child was on the way at this point. So like my wife as this was happening was like 3 or 4 months.
Did you meet your wife in Ukraine, or you met her here in the States?
In Ukraine. Yeah.
Okay.
Yeah. So basically, I looked at this situation. A year prior, we had gone to an event. It was a Thomas Edison event in Vancouver, and there was a guy there, and he was talking about the plastic bank. It's a really interesting idea. Was that people in India pick up plastic as it washes ashore off the Indian Ocean, and they deposit it in the plastic bank. And all the numbers just kind of work out so that the profit motive actually drives pulling plastic out of the ocean. So the idea is like, how could you set up another wheel like that? And so then this became the opportunity to try to set up that wheel.
So you're telling me, like, in India, if I get a piece of plastic and it weighs a half an ounce, I can get so many Indian rupees for that? Is that what you're telling me?
I'm not 100% sure, but at the time, it was he said he was a $200 million company, but like, I searched for it. I think they're there. Let me see.
So, I mean, there was an economic
things. That's for sure.
There was an economic incentive for somebody to clean the beach.
They were earning more than the shop back then, theoretically speaking. So, like, instead of working in the shop, they could just pick up plastic all day and they'd pull out more money.
Who was subsidizing? I guess the government was
subsidizing. Well, they were recycling the plastic.
Gotcha. Ah, okay.
Yeah. So
you wanted the same sort of hamster wheel. You wanted some incentive for...
Well, so like if you could build in either the social benefit or the environmental benefit and tie it to the profit motive, then theoretically speaking, it just keeps going. Right? And theoretically speaking, if you can get everyone in the middle to benefit as well, then you could, but like the social benefit in this case is the social benefit, right? But like they were calling it a triple bottom line company, so the goal was, can you build a triple bottom line company? Okay, fine. Maybe you can claim something about paper, but like really, we're teaching math. It's a social benefit.
Well, you think it's a social benefit, but that means everybody else has to.
Yeah, fair enough.
Like I never thought of teaching math. I never thought of my kid going to school being a social benefit, but obviously it is.
Yeah, that's for sure.
But it's never presented as that.
I mean, we feel it's an entitlement, but you can be entitled to a social benefit.
Yeah, no, I've never thought about it this way, but absolutely it's a social benefit because the more people that graduate and get educated, the better the world is, right?
Yeah, and so then, but this 4 out of 5 students, it broke down by income lines. So it was only the top income earners whose children were entering prepared. Now, if you take a look at this problem a little bit more closely, what ends up happening is that, like, we don't really have a reason to hold students back in kindergarten, first grade, second grade. In fact, most states will say third grade. When I was in California, they corrected me. They say we don't hold students back
Ever.
right? But
No
like,
matter
here's the
what.
issue: if I didn't understand the teacher in kindergarten, and I get to third grade, um, what they say is that on average, children in low income neighborhoods are 3 years behind their funded peers. So that means in low income neighborhoods, what this situation that I'm talking about is reality. You're in third grade, your understanding of numbers rivals a kindergarten first grader, and you're learning to multiply. This is an impossible situation for both the teacher and the student. At the end of the day, finances is a numerical game. And so, like, that's the thing, is that, like, if you're not versed in mathematics, then you're not versed in personal finances. You can't read the book in personal finances until you get to algebra. And so, like, if we're losing people at third, fourth, fifth grade, which is what it seems like, 75% of Americans can't calculate a 20% tip is the stat, right? So, like, if that's where we're losing people, means then it's not confusing as to why high school doesn't offer personal finances. It's just not possible to teach a student who can't read that.
But at this point now, yeah, I hear everything you're saying, right? And my brain, unfortunately, wants to put blame somewhere. So,
Okay.
who's to blame? Is it? I don't
You're
know.
gonna love this. That thing earlier about, like, the history of human beings, it becomes relevant now. Look, we evolved from monkeys. Let's just be honest, right? Like, fine, right? The best way that we knew how to teach mathematics 2 decades ago, 3 decades ago, 4 decades ago when I was growing up was, here, sit in this classroom, do this over and over again. Sooner or later, you'll understand it. That's what it was. So, like, I don't know if there's anyone to blame.
Okay. So you saw this problem. You saw it because you had a university professor getting a grant for this, but you didn't have a solution yet going into that.
Well, so they already kind of had a solution. They had a thing called Kids Play Math. It was programmed in Java. They not Java, sorry, Flash. But Flash was Java, by the way. So, like, when I looked at Flash, I'm like, this is Java. They were using Unity. It was like these students who had gone to the gaming program over there at the University of Denver. So their goal was not teach children mathematics. Their goal was, how can we make the flashiest game possible? And I asked him at the end of the conversation, because, like, he explained a lot of what I just explained to you, and I said, like, okay, fine, what do you have? He says, well, we have these games for 3-year-olds, 4-year-olds, and kindergartners. Teach them how to count, start getting them some addition. And so, like, I said, okay, fine, right? Like, how much math, like, we need to quantify it. How much math does it teach? And he says, well, that's hard to quantify because there's no standards for 3 and 4-year-olds. I said, well, look, man, you just told me a minute ago the average 3-year-old's doing this, the average 4-year-old's doing this, the average 5. But tell me, based on that, based on those averages, how much math did it teach? He said, well, it taught a year and 3 months. I was like, okay, well, now you're talking. So, like, basically what you're saying is you can solve this problem with what you've built right now. How much did they use it? How much usage was it for the 3 months? He said 10 minutes a day, 5 days a week. Okay, so, like, I was reading a book on how to run a team, and one of the first things it says on, like, vision is you should come up with a guarantee. So I asked him, can we guarantee it? He says, no, because the average is a year. I said, okay, fine. Could you show me the games? So he showed me the games, and there was these sheep in this pen, and you move them from one pen to the other, and they're walking, and he goes, you know what they love is when they answer correctly, this bus comes out, check this out. So man, this bus comes out. He's like, all the sheep get, and sometimes they get on top. And I'm like, okay. And he goes, and the kids love it. And I said, I'm getting rid of that, Alvaro. He goes, what? I said, that just took 30 seconds. Are you kidding me? That you like they're only using this 10 minutes a day. 30 seconds out of every question is watching to see whether they get in the bus or on the bus.
Yeah, right. Like it's not really 10 minutes at that point. It's more like 6, right?
How many questions they answered in that time? So yeah. So like, I say, yeah, no, that's the first thing I'm going to get rid of. I'm going to make it a 2-second animation. He goes, doesn't there have to be something for the children? I said, yeah, it's a slot machine. I'll make 10. I'll make 10 different 2-second animations. They'll figure it out.
Wow. And he was okay with that. I would think he would be nervous.
He said, well, are you a little bit afraid of them getting addicted? I said, well, we'll tell the parents to not let them use it more than 10 minutes a day. That would be a great problem, wouldn't it?
Yeah, that would be a good problem to have.
Be a great problem to have. So like, yeah, and so we created it that day. I said the mission will be empower children with mathematics. We'll guarantee 1 year of math in 3 months. He wouldn't let me say it until at least we had some people do it. But like, theoretically speaking, I told him, like, look, guy, if like it's not happening for someone, we'll get on the phone with them and either we'll make it happen, or we'll give them their money back. What's the problem? And basically, the first batch came out at 1.5 years. They used it like 22 minutes per week, and it was like
I wonder.
average time in the system was 10 weeks.
I'm wondering. See, what I would like to know is, I'm on your website now, and I was looking at the pricing for this. I'm assuming that I had a couple questions here, but I'm assuming the parent is paying that $50 a month for their student, or is the idea the school is going to pay that?
Well, so that's what the parent's paying. $50 per month for one child, $90 for up to 3. That includes 2 sessions per student per month with one of our math coaches that helps with math anxiety and any struggles. So like if the student's complaining, or if maybe they're answering a question wrong over and over again and you're having a problem with it, then fine, put them on the phone.
And the idea is that they would only need this for 3 months.
Well, so like average time in the system ended up being around 6 months. But like, I mean, when you're talking about those kinds of gains in 3 months, right? I mean, I measured the gain, right? That's the thing, is that we built the entire system kind of around, let's measure it. Because one of the guys was a professor and was like, well, I'm not comfortable with you saying anything unless you have scientific evidence.
I'm wondering, I'd be really curious to know if the parent is, I'm going to use the wrong word here, but forcing the kid to sit down for those 30 minutes.
10 minutes.
Or for 10 minutes. Or at some point, the parent doesn't have to do that anymore. The kid wants to.
Typically, it starts out with they want to, and then maybe they burn out, right? So that's why we put a timer on it. So like we started with nothing, but then we said, okay, let's put a 20-minute timer on it, because 10 minutes is too short. So 20 minutes was about right, because people stopped complaining.
I think 20 minutes makes sense because anybody can hold their attention for 20 minutes. That's when it kind of starts to slip.
Right.
So,
well, it depends on the age of the child. So like some 3-4-year-olds, if they tire at 5 or 6 minutes, if they start throwing the thing, they're like, oh, they got bored with it, or they're done with it. Okay, hey, let them stop. They ran out their attention span. That's what it looks like. Just come back tomorrow. It's okay. To be honest with you, like, because the curriculum for the younger students is so much less, they perform so much more. So that's why the results just up front were so big. It was the crafting of the rest of the curriculum on mine and Alvaro's part that then kind of was the rest.
But the idea is that this is for kids that are like what, from 3 to 8 years old or something, anywhere from pre-kindergarten to 3rd grade.
to 8th grade.
8th grade, all the way to 8th grade.
Yeah,
Okay.
through algebra. So, and that then encompasses anyone that's struggling with upper level mathematics. So if you're taking geometry or trigonometry and you're struggling, you come through our algebra course and now you kind of understand what the teacher's taught. The struggle is less. You start to enjoy math class. That's the kind of the feedback, the testimonial that we get is now my kid loves math.
Man, I wish I had known about this earlier. I have a 13-year-old that I think she's finally gotten over the hump a little bit on the math that she's doing in 7th grade. But I think she was struggling exactly the way, super smart kid. It's not like she wasn't smart enough to handle it.
Yeah.
But the first quarter of class this year, it's all been like, I don't understand what I'm doing. Not that she couldn't do the mechanics, she just didn't understand.
And I mean, this is the challenge, is that like math builds on top, right? So like if you didn't understand multiplication and you get to algebra and you see 7 times x, you give up. You're like, what? I don't know what this is.
Yeah. Are you, so my kids, people know this already from the show. I manage 7 kids, okay?
That's a lot of kids.
The last 2 are now high school and junior high. And my kids went to school in the Broward County, South Florida, Broward County School District. So I have not seen this learning platform before at all. This is the first time I'm even hearing about it. Are you doing, is it important to you? Or are you doing anything to get more of the school districts? I see Khan Academy everywhere with the kids. They have to do so many hours of that a week or something. But I'm wondering why I haven't seen this. And are you doing do you care for the school districts to sort of adopt some of this?
We made prototypes for the classroom, and we got some small amount of adoption, like maybe 50 classrooms, I think, maybe 20 classrooms, maybe 20 schools and like 30, some total 50. And then we made a school, and then we made a district portal. So now we're trying to talk to some districts. Got one salesperson kind of knocking on doors in 4 or 5 states. And then we started going to conferences, but like basically we got an application into the SBIR Ed. So the education SBIR grant could pay for us to create a version very specific for schools where the data layout of the accounts allow for district, school, like all the layers, and importing through clever ClassLink, et cetera, et cetera, et cetera. So that's kind of, fingers crossed, we're hoping in the next couple of months we get that. And if we don't, then, I mean, maybe we're doing it anyway. I don't know, like probably doing it anyway. And, but it would be definitely helpful because we could bring on people to help us do it.
I wonder, I guess you have a team of any size helping build the curriculum here, but at some point, I guess because this is so, I'm not going to use the word basic, but at some point you have the material. Does it ever really need to be updated? Talk about the content.
This particular
material.
product's done. I think that maybe if I need to expand now, I might have to create some other product. It might rely on some of the same technologies or the same, even some of the same curriculum items, because these were the essential topics. The goal of this product was, could we solve that problem? Could we take that 3rd grade student who's 3 years behind, catch his language up so that he can now participate in the 3rd grade classroom? And could we take a 4-year-old or 5-year-old and get them into multiplication and division? Because the research presented said that like students were already exhibiting this during play, but it was the adults in the room who didn't think they could understand the idea that weren't labeling it. And so it's like, cool, like we've proven that the research, the theory behind the research is accurate. And to be honest, they were working to do that anyway, these Clements and Sarama over at DU. So like, I think that like we accomplished the goal. And now the question is like, maybe the next thing that I could do that could be very helpful for people is logic. It requires them to have maybe completed elephant learning, right? Because like if you can understand the algebra, then you can understand the logic. You can now maybe speak to ChatGPT and have it create code and then evaluate the code. Because that's kind of the thing, is that like, yeah, okay, fine. If I spell out the function exactly, But if I don't, if I just kind of say, hey, I want this, and I describe it, there's always something wrong somewhere. And for
But why
college,
not? So you built a platform that gets kids essentially ready for junior high and high school, essentially. Junior high and high school math. Why not take it to the next level and get kids prepared for college level math, which is where I started this podcast, which I wish I could get the college math foundation again.
Well, so the way I
feel like I'm
see
lacking.
it is that there's a lot of people covering mathematics from the perspective of the school. And so, like, what I want to do is I want to cover mathematics. I want to cover topics that are useful to human beings. Probability theory, for example, I think is something that I use on a daily basis. Been using it for so long that I don't even know I'm doing it anymore. Just calculating the expected value of whatever bet, business-wise, stock-wise, whatever, I don't have to bet at McDonald's, but you know what I'm saying, right? Like if there's something out there and now hey, I gotta stake money to see am I gonna win? What are my probabilities? What is the expected outcome? What is the expected value of the bet? I could be at a blackjack table. Okay, at least you know what the expected value is. You know what I mean?
But I would imagine that what I would like to think sets Elephant Learning apart from similar platforms is the techniques you're using to deliver this material and teach, right? And if
we teach mathematics as a language. So most of the curriculum are these games, and the games are foundational, meaning that when you play it, you solve that puzzle, you are exhibiting the mathematical idea. So give me 5 things, give me 4 more things. How many things do I have now? You're exhibiting addition through the more. And so now you're kind of getting practice adding and you're getting practice counting, but at the same time, we write at the end 5 plus 4 equals 9. And now even if you didn't get it, right? If you're sitting in the classroom and you see 5 plus 4 equals, and you say, what does this mean? And the teacher says, give me 5 things, give me 4 more things. Well, you had that experience inside of Elephant Learning. So now you have something concrete to connect it to. So that understanding, that baseline understanding is there. So it's not about methods or techniques or so much of that stuff. The standards define understanding multiplication as being able to see a problem in the real world and then identifying multiplication and the numbers you need to multiply as the solution. And they exhibit that through word problems. So if you give someone a technique to solve a word problem, well, guess what? You just shortcutted your ability to determine if they understood multiplication to begin with. So you help cause the problem down the road when they see 7 times x. And that's what our system doesn't compromise on. We don't let you move on to the next thing until you've shown mastery in this thing.
So now that, let's say that this product is done, right? And I love that idea because things are allowed to be done. What are you doing day to day? What's your next thing now? What are you focused on? What are you doing day to day?
We had to fill out this grant application. That takes a lot. But then, we're going to have to do that at some point. So there'll be some coding. But I'm managing the Facebook campaigns because I'll be honest with you, the level of mathematics of business people is questionable. I don't want to say they don't have it because I see that they have it, but they do have the anxiety around it, and that's problematic. So, for example, I saw a course, some years back at MIT for data modeling and statistics, and I think it was out of the business department. It was an executive education. I said, why don't I take it? In this course, they went over linear regression, which I had never taken a course in statistics, so I had never seen the algorithm for linear regression. Then I looked at it and I was like, oh. And then they prove at the end that this answer that they come to is within 4% of best. I know exactly what that means. I don't know what best is, but this answer is within 4% of it. Cool. Okay, so you go over to Facebook. They have something called campaign budget optimization. basically, we are going to figure out the spend between your ad sets. Well, gosh, I wonder what they're doing. It's either linear regression or something like it, right? Maybe they got better than 4%. Maybe they're within 2% of best. That's why they're using it, right? I don't know.
Yeah.
So I tell this to my marketing people at the time. I say, I mean, like, are you running an algorithm? They're like, no. I said, you're not running an algorithm? They had 50 campaigns for me. They were choosing ad spend for 50 campaigns. They were coming in at an acquisition cost of around $79. I reset up their campaign in Facebook using campaign budget optimization. It came in at $72 or $74, something like that. And I said, it's amazing. You guys must be some of the best marketers on earth, because like I gave the algorithm 3 ad sets and optimized the spend. It's doing 74 and like you're within $5. So like,
I'm also wondering now, since you're on the technical side, kind of what your stack is for this platform. What are your front ends, back end systems, databases? Like, is it running in the cloud?
MERN. It's a Mongo Express React Node. MERN.
I love Mongo. Sometimes you tell people Mongo and they shiver, but I love MongoDB. I've had a lot of success with the database.
I know what you mean. It's the relationship fetches that are a little bit of a PETA.
But I'm pretty much a full-time Go developer. I don't do much with Node. JavaScript is just not my jam at any level.
Yeah, we do everything in CoffeeScript.
Okay, yeah, the TypeScript is good. I feel at least with the TypeScript you get some of that compiled language feel, but
yeah, but it's got the typed variables. Like if you're going to do JavaScript,
do JavaScript.
And you know what I love about CoffeeScript is it compiles to the most bland JavaScript possible. Like like it's 1995, 1996 JavaScript. It's just going to be good forever.
What is it?
It's not going to change the standard at some point. And like now your if statement it behaves differently.
How many of these Node services do you have to run to sort of keep up with the traffic?
Oh, well, we are still on, like, you have the HTTP front ends, and then you have a back end service, and I think, I don't know, not a ton.
Not a ton. It's not that. The cost of running the system isn't that bad.
I mean, we pay more maybe than we have to, because I'd like my fetches to be fast out of the database, you know what I mean? Like, I don't want...
Yeah, that's fair. That's fair.
I mean...
You're running on AWS then?
In memory databases.
That's cool. Well, this is awesome, dude. I really appreciate it. We're just here at the end here, out of time. So I've been on the website while we've been talking. The website looks great. Everything looks pretty solid. I even shared the link with my wife. I wanted her to look at it. She was an educator for a few years, so I wanted her to look at it too, because I think the story behind it is really, I've experienced the need for this. Let me just put it that way. I wish I had seen this earlier. So I think that's really cool. So if anybody listening to this, and we'll get in the show notes, wanted to reach out, had other questions for you, what's the best way for somebody to get in touch with you?
Oh, the best way is if you just go to elephantlearning.com, you'll find us. A lot of people connect me on LinkedIn. Though I don't understand why I don't ever post there. Maybe I should post there more. But you can also find me on Facebook. I just flipped my profile into digital creator, so you can actually follow me now. But you can also follow Elephant Learning on Facebook. There's 54,000 people there, so that's where 9,000 now is where I post if it hey, I want 59,000 people to see something, which is rare, to be honest.
I did want to ask you where the idea of using an elephant came from.
Oh, that's a great question. Why not? So when that guy from Digidata called me up, he asked me, well, okay, I got to go back and pitch you to the board. You got to come up with the name of a company. And at that point in time, I had created a search thing using web objects because they had this special merging thing. I don't know if it was fast, but you couldn't do it. So it was I can do this merge and I can somehow filter. But Google came out with something. So I said Denver Search. He says that sounds like a headhunting firm. I said, oh, okay. Yellow Duck. He goes, why Yellow Duck? I'm like, I don't know. Like, I like the idea of a duck, and then like if it's yellow, then it's like the rubber ducky thing. So that's kind of cool. And he's like, yeah, no, I'm not going to tell that to the board. So I said, okay, fine. I don't know. All of these things seem to be 2 words because I worked for a cardinal peak. I worked for a magpie. I was like some sort of animal, some sort of. So I was like, yeah, fine, elephant head. And he's like, I like it. I'm doing it. Elephant head. So then we were in.
That's funny. Just so it's like the universe named the company.
Yeah, why not?
Just came from the universe, man. All right. Well, we're totally out of time, man. I really appreciate the time and the story and really good stuff. All right. This is the Ardan Labs podcast signing off, and we hope to see everybody again real soon.